Hello everyone, my name is Manohar. I'm a data science trainer and consultant. Today we are going to discuss about the topic that statistics with Python. Statistics is a separate subject, but in this session we will discuss about statistics, how much is needed for the data science. Let me tell you agenda for this discussion. Firstly, I will explain what is statistics, where we use statistics, why we need statistics. After that, I will explain frequently used popular terms in statistics. They are population and sample. After that, I will explain types of statistics. We have two kinds of statistics. They are descriptive statistics and inferential statistics. I will let you know their use as well. After that, I will explain Gaussian distribution. And in the end of the session, I will explain types of distributions and its applications. Firstly, let me explain what is data. Data is a collection of facts, numbers, quantities, information, graphs, measurements, and observations. Simply, data means the information. Without information, we can't predict the future. Without information, we can't communicate with another person. What I'm passing to you? The information. Simply, without data, we can't do anything. So, we have to gather the data to do some kind of operations, right? Let me tell you what is statistics and why statistics. Statistics is the area of applied mathematics which is concerned with data collection, data interpretation, and data representation. Statistics is used to solve the problems and to represent the data into a graphical format. Why we need to represent the data into graphical format? Let me tell you an example. Suppose, consider a population survey. In that population survey, bunch of data will come, right? If I give the data to you and if I ask a question after 10 minutes that what did you understand from the data? Then what kind of answer you tell to me? No answer will come from you because no one can't analyze thousands of rows and columns in a less time. Human brain can get more information from graphs rather than spreadsheets, right? So we need to represent our data in the form of graphical. With help of statistics, we can represent the data into graphical format. Without statistics, representation of data into the graphical format is not possible. In the right side, you can observe a flowchart diagram. In the diagram, there is a data, statistics, and information. I already explained to you about the data, right? After collecting the data, make the data meaningful. After we have to feed the data to our statistics, then that gives us the data in the form of graphical format. From that graphs, we will get the information. From that information, we will get knowledge and facts. On the left side, you can observe some graphics. There is a bar and pie chart. Consider population survey again. If I take the population on y-axis and year on x-axis, then in the 2010 population is like this. In the 2020 population is like this. You will understand, right? I can gather the knowledge from the graphs. If president sees that population graph, then they will take the decisions on that society, how we rule it, and may I change any rules and regulations, some kind of decisions they might be take because people are increasing, then more place is occupied rather than farming, then giving the food to the people is difficulty for authorities, right? Okay, let me explain two popular key terms in statistics. They are population and sampling. Population is called a group of samples. Sample is a part in a population. Let me tell you an example to you to understand what is population and what is sample. Consider our Earth. On the Earth, more than 116 countries are there. if I talk about entire earth, then you have to understand I'm talking about all the countries on the earth. That is what the population is. And if I talk about a specific country, then we have to understand that is sample. Let me give you one more example. In the slide, you can observe one image. In that image, you can find target population and sample. Just assume target population is a city. If you want to construct a house, will you recruit all the people as employees? No, right? From that entire city, you will choose the people who are more interested and who are skilled persons. If you choose some people to construct house, then that is sample. To picking the items from population, there are some techniques. That techniques are called sampling techniques. Let me explain one sampling technique, that is random sampling. You can observe one picture in the slide. In that there are some people. From that people they are taken three people randomly. So we have taken it as a random sampling. Let me tell you an example to understand this random sampling and all. Suppose consider a company conducted interview. For that interview, more than 500 people are attended. Company recruit only three people because their requirement that is. Then there is an equal probability to hire each person. Right? There is equal probability to hire each person. If we select the samples in this way, then we call it as our random sampling. Okay, let me explain types of statistics. Statistics is categorized into two types, that is descriptive statistics and inferential statistics. Descriptive statistics will give you the description about the entire population, whereas inferential statistics will give you the description about the samples. Let me tell you an example to you to understand this descriptive statistics and inferential statistics. Suppose consider a door manufacturing company. To the door manufacturing company, if customer gave 1,000 doors manufacturing project, then if customer desires the company that I want to know the strength of each door, then company will randomly select few doors and they check for the strength on the doors. Because they use the same material and same standards, this is what the inferential statistics. And come to the descriptive statistics. If customer asks company, I want to know the cracks on the doors, then company need to inspect each and every door and they have to give the description of those. This is what the descriptive statistics. Again, the descriptive statistics is categorized into two types. They are measure of central tendency and measure of variability. Measure of central tendency is always looks for the mid value in the samples, and measure of variability always looks for spread of the samples. Here the spread of the samples means how the values are deviated from the mean. What is the difference between sample to sample? It will give the results like this. Then how this measure of variability is interlinked with the data science? You may get the question right. In the data, if there are samples with a large difference, we may get less accuracy. So we need to reduce those values nearby a value without changing their meaning. How we reduce? I will explain to you in the later slides. Under measure of central tendency, mean, median, mode are there. And under measure of variability, there is a range, IQR. That means interquartile range, variance, standard deviation, and come to the inferential statistics. Under inferential statistics, Pearson correlation, p-value, z-test, hypothesis testing, and t-test or ANOVA. ANOVA means analysis of variation. Let me explain each one by one. Let me explain about the mean and I will let you know the difference between the population mean and the sample mean. Mean calculation procedure is same, but indication is different. Population mean is indicated with the letter mu and sample mean is indicated with x bar. We will take summation of all the samples and we divide the value with the number of samples. Then we get the mean value. Let me tell you a best example for the mean. Suppose consider you and your friends are going to a restaurant. All friends are decided that whatever the item you eat and whatever the price of that item, we have to pay the bill equally. If friends are decided like that, then what they have to do? They have to do that, take the summation of each person bill and divide that value with the total number of people, then they will get some value. Each person has to pay that price. In this way, we take the mean of all the samples. And let me explain the central tendency. Here in the slide you can observe one picture that has mean, median and more. What is mean? Mean is calculation of all the samples and divide that value with the number of samples. Here, for better understanding, I have taken the examples with the mean itself. But we can't calculate the mean for the characters. We can calculate the mean for the numerical values. Whenever you consider the mean values, then only we can calculate the mean. This is the main formula and come to the median. Here there is a data like 2, 4, 5, 6, 7, 8, right? If we want to calculate the median, we consider that how many samples are there totally. Totally how many samples are there? 1, 2, 3, 4, 5, 6, 7 samples are there. If I divide that 7 samples with 7, then I will get the value like 3.5. If I round up that value, my value will come as 4. That fourth index value will be come as my median. The fourth value is a 6, 1, 2, 3, 4. This is my mean. Here 6 is the median. I consider it as my mean. Okay, come to the mode. There is a data like 3, 5, 1, 5, 2, 1, 5, 6, 5, 8. In that data, I will consider mostly repeated elements. What are the repeated elements here? 5 and 1. Those are repeated elements, then which element I have to consider as my mode? So, which highly repeated in the data, that element is our mode. Here 1 is repeated 2 times and 5 is repeated 1, 2, 3, 4. 4 times 5 repeated. So, which one is highly repeated? 5, the number 5 is repeated highly. So, we consider it as our mode and I consider it as our mean. And let me explain the variance. Variance will give the results as how the samples are spreaded. Let me tell you an example to you to understand what is variance exactly. Suppose consider a family. In that family, men and ladies are there. If we want to know how the hair length spreaded with each other in their family, then we have to measure each person hair in the family. After we have to take the mean of their hair. After that we subtract each of the person hair length from the mean and make a square and take summation of that. Later divide that value with the number of persons, you will get the variance. Here there is a variance formula. Variance is indicated with a sigma square. Here x indicates the sample values. How many are there? This is 1, this is 2, this is 3. This value will be indicated with x. And here you can observe the mean. Mean is nothing but, mu is there. Mu is nothing but the population mean. We have to take the mean and mean of all the samples. We have to substitute here and make a square of that. After make a summation of that and divide that value with the n. N means number of scores or number of samples. In the left side, we can observe one image here, that in that image there is a curve. That curve is called bell curve. Here, this mu is our population mean. This 34.1 percentage indicates that from the mean, this value is lesser. Suppose consider from the mean, I am measuring this person hair length. Then this saying that this person hair length is less than 34.1 percentage from the mean, and this person hair length is 13.6 percentage less, and this person 2.1 and 0.1. We calculate the variance like this. Then you may get the doubt how variance is interlinked with the data science. Suppose consider the data came as like 0, 2500, 10,000, 50,000 like that. Then if you observe the data, there is a much of difference between the sample to sample. If we train our model with that samples, then we will get less accuracy. We have to reduce those values to a certain value. Then only we will get more accuracy, right? How we reduce the values? Let me explain the standard deviation. With help of standard deviation, we reduce the values to a certain value without changing the mean of that value. Suppose consider the value 625. 625, if we want to reduce that value to a certain value, just apply the root on that value, then you will get the value will be reduced. From 65 to the value will be reduced to 25 without changing any meaning, just by applying the root. In the previous slide, you can observe in the formula, the variance is indicated with the sigma square. But here the standard deviation is indicated with the sigma itself, because the square will come to the side, then it will be a square root of that value. In this way, the values will be reduced to a certain value, then only we will get the high accuracy. In the pixels, we can observe the values are 10, 20, 30, 40, 50, 60, 70 are there when I applied the standard deviation and variation on that. The values are converted into the sigma values, like -3 sigma, -2 sigma, and -1 sigma, mu 1 sigma, 2 sigma, 3 sigma, like that. With the help of this standard deviation, we reduce the values into a certain value. Okay, let me explain the Pearson correlation. This Pearson correlation will tell you how the variables are correlated with each other. Suppose consider the weight and height. If weight is increases, then how the height is deviated from that? If I take the weight on y-axis and height on x-axis, then how they are deviating? If weight is increases to a person, then how height is increasing or how height is decreasing? If weight is increasing and if the height also increasing, then we consider there is a positive correlation between those variables. And come to the second image. In that, weight is a constant. Weight is not changing, but height is changing. Then that time we give the results as there is no correlation between those variables. And come to the third image. Here you can observe weight is decreasing. Frequently it is decreasing and the height is keep on increasing. There is a correlation, but there is a correlation as negative. Whatever the correlation that is, we're expecting the correlation between those variables. Whenever we are training our model, we consider those features are highly correlated with other features. We consider those features itself then only we will get much of accuracy. Otherwise, we won't get any much of accuracy. So that's the reason this Pearson correlation will be more helpful for in data science. And let me explain the distribution. Distribution in statistics is a function that shows the possible values for a variable and how often they occur. The probability density function of the normal distribution is also called Gaussian or bell curve. The most important continuous random distribution, as noted on the figure, the probabilities of intervals of values corresponding to the area under the curve. And let me explain the Gaussian distribution. In probability theory, a normal or a Gaussian or Gauss or Laplace-Gauss distribution is a type of continuous probability distribution for a real value random variable. This Gaussian distribution is calculated with mean and standard deviation. If we plot a normal distribution, then we will get a bell curve. When I explained to you about the variance and standard deviation, I already explained to you about shape that bell curve, right? Normal distributions are important in statistics and are often used in the natural and social sciences to represent real value random variable whose distribution are not known. Their importance is partly due to the central limit theorem. Central limit theorem states that under some conditions, the average of many samples or observations of a random variable with finite mean and variance is itself a random variable whose distribution to a normal distribution as the number of samples increases. Therefore, physical quantities that are expected to be the sum of many independent processes, such as measure errors, often have distributions that are nearly normal. Moreover, Gaussian distribution have some unique properties that are valuable in analytic studies. For instance, any nonlinear combination of fixed collection of normal deviates is a normal deviate. Many results and methods such as propagation and uncertainty and least square parameter fittings can be derived analytically in explicit form when the relevant variables are normally distributed. And let me explain the types of distributions. Distributions or some types. Normal distribution, skewed left distribution, skewed right distribution, uniform distribution, binomial distribution. Let me explain each one by one. Firstly, let me explain about the normal distribution. If we draw a histogram and make sharp those edges, it will appear like a bell curve. I already explained about this normal distribution where we discussed at Gaussian distribution. And let me explain the skewed left and skewed right distributions. Graph the values on the right side of the distribution taper differently from the values on the left side. These tapering sides are called tails and they provide a visual means to determine which of the two kinds of skewness a distribution has. Negative skew. This is called skewed left distribution. The left tail is longer. The mass of the distribution is concentrated on the right of the figure. The distribution is said to be left skewed, left tailed, or skewed to the left, despite the fact that the curve itself appears to be skewed or leaning to the right. Left instead refers to the left tail being drawn out and often the mean being skewed to the left of a typical center of the data. A left skew distribution usually appears as a right leaning curve. And come to the positive skew. That means skewed right distribution. The right tail is longer. The mass of the distribution is concentrated on the left of the figure. The distribution is said to be right skewed, right-tailed, or skewed to the right, despite the fact that the curve itself appears to be skewed or leaning to the left. Right instead refers to the right tail being drawn out and often mean being skewed to the right of the typical center of the data. A right skewed distribution usually appears as a left learning curve. Skewness in the data series may sometimes be observed not only graphically but by simple inspection of the values. For instance, consider the numeric sequence 49, 50, 51, whose values are evenly distributed around a central value of 50. We can transform this sequence into a negatively skewed distribution by adding a value far below the mean, which is probably a negative outlier. Example 40, 49, 50, and 51. Therefore, the mean of the sequences become 47.5 and the median is 49.5 based on the formula of non-parametric skew defined as the skew negative. Similarly, we can make the sequence positively skewed by adding a value far above the mean, which is probably a positive outlier. Example 49, 50, 51, 60, where the mean is 52.5 and the median is 50.5. As mentioned earlier, a unimodal distribution with zero values of skewness does not imply that the distribution is symmetric necessarily. However, the symmetric unimodal or multimodal distribution always has zero skewness. And let me explain the binomial distribution. In probability theory and statistics, the binomial distribution with parameters n and p is the discrete distribution of the number of successes in the sequence of n independent experiments, each asking a yes or no questions and each with its own boolean valued outcome. Success or yes or no with probability p, or failure or false or zero with probability q. A single success or failure experiment is also called a Bernoulli experiment, and a sequence of outcome is called a Bernoulli process. For a single trial, that is, n is equal to 1, the binomial distribution is Bernoulli distribution. The binomial distribution is the basis for the population binomial test of statistical significance. The binomial distribution is frequently used to model the number of successes in a sample of size n drawn with a replacement from the population of size n. If the sample is carried out without replacement, the draws are not independent, and so the resulting distribution is a hypergeometric distribution, not a binomial one. However, for n such as larger than small n, the binomial distribution remains a good approximation and is widely used. And let me explain the uniform distribution. Think about a dice. It has 6 sides numbered from 1 to 6. We roll the dice. What is the probability of getting 1? It is 1 of 6. So 1 6, right? What is the probability of getting 2? Once again, 1 6. The same holds for 3, 4, 5, 6. Now, what is the probability of getting 7? It is impossible to get 7 when rolling a die. Therefore, the probability is 0. The distribution of an event consists not only of the input values that can be observed, but is made up of all possible values. So the distribution of the event rolling a dice, the probability of getting 1 is 0.17. The probability of getting 2 is 0.17, and so on. You are sure that you have exhausted all the possible values when the sum of probabilities is equal to 1% or 100%. For all other values, the probability of occurrences is 0. With this, I would like to end the webinar. I would like to meet you all once again in my next webinar with lots of interesting facts and information. Thank you once again and my best wishes.